short overview. I started putting this together I put this together a while ago. I started timing it this morning. It was about 20 minutes. So I really cut it down. So we're at about 8 minutes to just give you, really an overview of the overview. So let's get into it. What exactly is artificial intelligence? What is this stuff that can play chess better than people, that can drive better than people, that can do all of the crazy things that we're seeing in technology today? So I bring for you a couple of quotes. The first is from John McCarthy. He's one of the founding fathers of artificial intelligence. He coined the term artificial intelligence at the Dartmouth workshop in the 1950s. He says, artificial intelligence is the science and engineering of making intelligent machines. So that's very good, and it's very general, and so it doesn't really help us that much to really understand what exactly is this artificial intelligence. So I bring you his colleague Marvin Minsky, who was also at the Dartmouth workshop in the 50s, and he says artificial intelligence is the science of making machines do things that would require intelligence if done by people. So basically what he's saying is that we're trying to get machines to do intelligent things that people do. There's many other explanations which basically feed off of these same types of definitions. At the end of the day, what we're trying to do is what God did. We're trying to make humanoids just like God made humans. And so now the question really is, how do you do that? And that's our question today. What exactly is artificial intelligence? It started, like I said, in the 50s. Artificial intelligence at the time, for those first decades, was basically telling machines explicitly what to do based on logic, on expertise. If you wanted a machine to execute a task, you had to tell it explicitly through rules that were hard-coded into machines. Then in the 1980s, due to the development of hardware that took us from giant servers that filled rooms that all they could do was add a couple of numbers to the kinds of things that we have today. So machine learning evolved, and machine learning basically makes a break from what's known as GoFi, good old-fashioned AI. And you don't explicitly code what you want the machine to do. Rather, you give it data. Tons of data, and an algorithm processes that data and builds a model, which I'll show you in a minute. And that basically allows the machine to what we call learn and then predict and perform. And then finally, in the past few decades, this machine learning has given rise to a subset, which is known as deep learning. And I'll explain what that is at the very end. So like I said, there is this evolution of artificial intelligence, the algorithms of it, which paralleled the evolution of hardware that was able to process so much data that's what we call big data. It's able to crunch numbers in a mass scale that couldn't have been conceived in the 50s, 60s, 70s, really even in the 80s. So what exactly is machine learning? I bring you Arthur Lee Samuel, who's really the guy who coined the term machine learning. He became famous for building the first checkers game, which learned on its own. And he says machine learning is the field of study that gives computers the ability to learn and even improve themselves without being explicitly programmed. And so that's the break between good old-fashioned AI and the machine learning that we have today. It basically learns to identify patterns, and with minimal human intervention can give sophisticated predictions. And I bring you this quote from Mark Zuckerberg, who's one of the big names in AI ethics. And he tells us that even though we use the term learning, it's not human learning. These aren't machines that have consciousness and the kind of cognitive processes that give rise to human learning. We use all these terms like learning and cognition and so forth, basically just to talk about what the machines are doing, but they are not human. They don't process the data like the way people do. Okay, so now what exactly is machine learning? Machine learning breaks down into three categories: supervised learning, unsupervised learning, and reinforcement learning. So let's see exactly what those three are. Supervised learning basically breaks down into two categories: classification and regression. So classification basically says, I want to classify things. Let's take a email spam filter. So I'm supervising. I give the machine real emails that I tell it, I say, this is not a spam. And I give it real emails that I say, this is a spam. And now I give it hundreds and hundreds of thousands of mails, and it processes the data and it says, oh, look, every time somebody says free sign up now, that's a spam. And everybody said time that somebody says, hi, honey, what are we having for dinner? That's not spam. And it goes through, it processes all this data, and it builds a model. And so that model then can be used. And now I give it new mail that I haven't seen and it hasn't seen. And based on the history of the and the model that it built, it can now tell me if the new mail is spam or not spam. It classifies it. Okay, so this is supervised learning because I have told it what the data means, and then it later tells me what new data means. Regression is another process of supervised learning. To give you an example, basically it's doing curve fitting based on mathematical modeling. You give it, let's say, for example, I want to know the house prices based on the house size. Of course, house prices are based on many other things. This is a very simple example. So I give it these red X's are data that I know. A 500 square meter house costs $100,000, etc. And then I let the system run, and it does what's called linear regression. It places a line to it. And so now when I ask it, so how much is a 750 square foot house? It goes to the line and it says, oh, that's $150,000. Now, a single line, a straight line is not the best way to do curve fitting. We can do a quadratic curving. We can go even to more sophisticated models. But at the end of the day, I give it data. I tell it what the data means. It builds a mathematical curve. And now when I give it new data, it goes to the curve and gives me the output prediction. This is supervised learning, 100% math. Then there's unsupervised learning. Unsupervised learning means that I don't tell it what the data is. I just give it tons of data and it figures out something from the data. There are two types of unsupervised supervised learning, clustering and association. So clustering is where I give it all this, let's say in this example, customer purchasing behavior, and it sees different types of people and it clusters them, and it says, oh, the green people, they're the big spenders, the red people are the low spenders, and the people in other colors are different things. Why is this interesting? Because if we look at this XY curve, what it did was, these are all data points of people, where they live and how much they spend, and it's able to cluster them and say, oh, these are the big spenders, these are the low spenders. And now when I get a new person that I don't know what he is, if he falls into one of these circles, so I say, oh, big spender, little spender. Based on unsupervised learning, I gave it data, it clustered it, and so now anybody that fits into those clusters can give me the output. Associative learning, it's basically associations. So like, let's say, for example, we're looking at the receipts of people who went to the market. And the machine will learn that people who buy milk and bread also buy cheese. Or they look at the receipts from the sporting goods store and say, people who buy winter coats buy winter boots. Now, for us, this is all very obvious. What are you telling me? But I'm saying all I give to the machine are sales receipts, and it makes these associations and figures them out. Why is that interesting? Well, it's interesting. Of course, you can target people who are buying stuff, but what's more interesting, you can use it in other places, like in medical diagnosis. So you can say, oh, look at people with symptom X and Y all have disease Z. And so now this associative learning system can now predict diseases and so forth. And finally, the most sophisticated machine learning is called reinforcement learning. And reinforcement learning is where the agent, meaning some computer program, receives rewards for performing correctly and penalties for performing incorrectly. So what is that? So if you take a look at this little diagram here, so you have some agent, a little computer or robot, that he needs to learn where to go and where not to go. So he has some policy that he follows to where he should go. He thinks he should go to the fire, but that was the wrong choice. And so he gets penalized and he gets minus 50 points. So now next time he knows, don't go to the fire. This is a very simple example. The more sophisticated one is the AlphaGo game. For those of you who haven't seen the movie of AlphaGo, you should really watch this movie. It really talks about reinforcement learning and machine learning and how AI is so sophisticated. Go, for those of you who don't know, is orders of magnitude more sophisticated than chess. And AlphaGo is a system that was trained only on reinforcement learning. It was given the rules of the game, and it was given points for winning and negative points for losing. And it was able to learn on its own and beat not only the human champion, but its predecessor machine champions. Anyway, all of this, we should mention, is based on what are called neural networks. Neural networks are a kind of model of how our brain works. So our brains have neurons, which are basically electronic switches that have inputs and outputs, and they're wired up to all kinds of other neurons. And just like a circuit board passes information and makes decisions in a circuit board, it makes it in our brains. So we model that. We have a switch and we have a network of switches. At the end of the day, it's all computer code, whether it's writing hardware or it's writing software. And then we build this into what are known as deep neural networks. They're called deep because they have many layers deep. Here we just show one hidden layer. In deep neural networks, they have many hidden layers, and this allows for very, very sophisticated computing and processing of data, and all that mathematical modeling that I showed you before is done in an incredibly sophisticated way with deep neural networks. At the end of the day, my message, and this is my last slide, is that AI is just math and statistics. It builds very sophisticated models based on very complicated mathematics, but at the end of the day, it's just math and it's just statistics. Even though it behaves like us, that really has to make us question do we think, and what makes us special, that we have consciousness that I assure you today the machines do not, but tomorrow people are working to make them have even consciousness. Thank you very much.